Hello and welcome to this quick introductory guide to Alibre Atom 3D. So in this guide we're just going to quickly run through how to model a couple of parts, how to put them together into assembly, and then how to create a drawing of that assembly, just to give you a brief overview of the sort of main workspaces and functionality of the software. So this is the Alibre Atom 3D home window. And from here we've got access to all of the main areas. So under this create new section, the first option here is to create part. So if we click on that, that will bring us into the part workspace. A couple of little details of to start with. So we've got three main areas of the interface. We've got all the modeling tools on the top ribbon here. On the left we have the Design Explorer, so all sketches and features you create in building a part are listed here, and you can edit them, anything you've created from this Explorer on the left. And then we've got the main working area in the center here. A couple of useful things. So view controls, with the mouse, if you hold down left and right mouse buttons together and then drag, that rotates the view. Scrolling the middle mouse wheel zooms, and it zooms to wherever you put the cursor, so that can be quite useful for navigating around the model. And then if you need to pan the view, hold down middle mouse button and drag, and that allows you to pan. Now to create a part we need to start with a sketch, as any flat face can be used as a plane for sketching. In this case, because this is a new part, we don't have any flat faces on the model, so we can use one of the green reference planes that the software provides. So for this case I'm just going to select the XY plane by left clicking once on the edge of the plane in view, and then we're going to start a sketch by going up to this option top left and click on the Activate 2D Sketch button. And for this we're going to create a cross section that we're going to use to revolve, so effectively like a turning operation, to revolve the body and head for an M8 socket cap screw. And to do so we need to draw something. We have on the menu here, we have a section called sketch figures, and the very first option is line, and this just allows us to draw shapes using straight lines. So I'm going to left click on the line tool, and then to start the shape I'm just going to left click once and then move the mouse over to the right, and you'll notice if I keep the mouse in line with the start point, we get it snaps horizontal, and we get a little arrow symbol above the line to say that that's now going to be a horizontal line, which is what I want in this case. So I'm just going to left click again to end that segment of line, and just note, don't hold down the mouse button when you're drawing lines. You just click once, move the mouse to where you want the line to go, and then click again. Now the line tool will continue drawing, so in this case that's fine. I want to continue, and I want to move the mouse. If I move it so that we are perpendicular to the first line we've drawn, the software will automatically snap to 90 degrees. So that's what I want. I'm now just going to click again. I'm going to continue drawing. I'm going to start. I'm going to bring my mouse back to the left, and again, because I've got this at 90, the software's snapped and added a parallel constraint between the first line we've drawn and the one we're drawing now. So that looks good. I'm going to click again. I'm going to move up and get that perpendicular snap. I'm going to come across to the left, and when I get in line above the first point we started with, you get a little red guideline. That's just to say those are lined up, and I've also got the perpendicular snap there, so that's what I want. I'm going to click, and then I'm going to go down and close the shape and click on that first node we created. And because we've created a closed shape, the software will stop drawing lines. If you did need to draw an open shape, you can stop drawing at any stage by hitting the escape key on the keyboard. So now we've got our basic profile. I can apply some dimensions to that. So up on this top toolbar there's a dimension button, so I just left click on that, and so the first thing I'm going to dimension is this upper line here. So if I just left click once on that line, then left click again, that gives me the dimension. So the first click is to select what you want to dimension, and then Second click is to position the dimension into the view, into the drawing. So I'm just going to type in 30, and I can either press enter on the keyboard or click the green tick to accept that, and then it'll update the sketch to match that. Another dimension, so the length of the head, if we left click on that and then left click again to place the dimension, that wants to be 8mm, and I'll click the tick. And then for the ends, we want this is going to be a revolved section around an axis, so we want the radius of the part rather than the diameter. So for this is going to be an M8 bolt. So we'll just use the nominal size. So we'll make this 4mm. When that's revolved, that will give us an 8mm stud, and the radius of the head is 6.5. Now you'll notice that the colour of the sketch is changing. Just drawing attention, so bottom right we have a little key here. So these are the degrees of freedom colors, and if you don't have this key or color coding, there's just this option top right of the 2D sketch menu. And what this is basically saying is that red is undefined, we haven't given it any sizes or positions. Orange, like we have now, is we've defined the shape and size of it, but it still doesn't know where that shape should be positioned in relation to the coordinate system. And then black is fully defined, which is what we're aiming for when we're creating sketches in Alibre. So if I just to demonstrate, if I left click on the select tool, then hold down the mouse button and drag on one of these points, you can see that that shape is defined in size, but as I say, it's free to move. So that's why we need to give it a position. And now what we need for this to revolve, we can use the x-axis here as our axis for the revolve operation. And I just want this edge to be coincident with that. I also need to provide some sort of reference left and right, so quite a convenient option. We have a selection of constraints here which just allow us to apply sort of mathematical relations between things, such as parallel, perpendicular. On the bottom row here we have one option that's called midline, so if I select that, left click on this bottom edge and then click on the origin point, what this will do is it'll center this little edge onto the point, and so that is now a fully defined sketch. So with that done, we can click the green deactivate sketch button. I'm just going to rotate my view into 3D just by holding down the left and right mouse buttons so I can see more clearly what we're doing. And then with the sketch selected, so you can see this is highlighted in blue, and if you did click off it, you can pick it by left clicking in the picking it in the tree on the left there. I'm now going to go to the boss, add material section of the menu, and the second option here is revolve, and so this just sends a cross section around an axis. So I'll click on the revolve button, and this will bring up the revolve boss dialog. We've got the sketch specified in sketch to revolve, so the only other thing we need to tell it is an axis to work around. So in this case, if I can pick the x-axis either in view or I could select it from the tree. And then we also have some options on the angle. By default it'll go 360 degrees, which in this case is what we want, so I'm just going to go OK, and that has created the base feature for our bolt. Now I need to create the socket on the end of the bolt. So as I mentioned before, any flat surface can be used as a sketch plane. In this case we can use the flat face on the end of the bolt we've just created. So I'm going to select that face and then go to activate 2D sketch. So for this we need to create a hexagon. Now we could draw that using the line tool, but there is a shortcut. So under sketch figures we have a polygon tool, and under this we just need to tell it how many sides we want. So the default is 6, that's fine, so I'll leave that on 6. And now I want this hexagon centered on the origin point, so if I just left click on the origin point and then move the mouse up, not holding the mouse button down, and you'll see as well we get a little red guideline, so that's going to snap it so that the top edge of the hexagon is horizontal. So I'm going to left click again to position it, and then we just need to hit the apply button, and that'll add that to the sketch, and then we can click the close button to remove that dialog. So now we need to do two things. We need to provide a size for the hexagon. We also need to control the angle. So I'll do that first. Under constraints, this option here, bottom left corner, is horizontal. So I'm just going to click on that and then click on this top edge, and that's just to say I want to lock that top edge horizontally. And now we can go to the dimension tool. I'm going to go to dimension, and then we have the option to dimension between two things. Is you go to click on dimension, click on the top line, click on the bottom line, and then that will give you the dimension between those two, and then left click again to place a dimension. In this case it should be 6 mil, and that is now color coding's gone to black, so that is fully defined. So we deactivate sketch, and so for this one we want to cut the socket into the body of material there. So we can use the extrude cut option. So that's under the cut remove material section, there's an extrude option, so we go into that, and this has gone defaulted to a negative dimension because we're trying to cut into the part. Positive would be away from the part, so that's correct. And the depth of the socket should be 4 mil, so I'm just going to change this to -4. And if you want to see what that's going to do, just click in another box in the dialog and the preview will update. That looks good, so I'm going to go OK, and that's created our socket. And final detail is I want to add a chamfer onto the end of the part here. So I'm just going to go under the part tools. We have some options for adding details like chamfers, fillets, that sort of thing. So I'm going to select the chamfer tool. Now type equal distance, so this will give us a 45-degree chamfer. That sounds fine. You can, if you needed a chamfer of a different angle, there are some other options in there. So I'm going to change the size. I want 0.5 mil chamfer, so I'm going to change this to 0.5. And then to apply this, I just need to click in the edges / faces to chamfer box. Otherwise, it will jump back to the previous value. So that's now set that at 0.5. And I just want to pick the edge on the end of the bolt here. So you can pick faces or edges. So in this case, I just want to select the edge, hit apply, and then click the close button. And that is the bolt finished. So at that I can go to the file menu and save, and then I can save this as M8 by 30 socket cap screw, and save. And with that, we can then click the cross top right to go back to the Alibre Atom 3D home window.